When I look at the bioeconomy and innovation in the bioeconomy, I think it is a blend of old and new technologies. So there's nothing that we can do in the lab here that isn't fundamentally rooted in chemical engineering approaches. And that's a field that's been in existence for over a century, or at least a century. But at the same time, we have this whole new suite of approaches and technology associated with genomics, metabolomics, proteomics, engineering microbes, and understanding what's going on within the cell. So there is this blend of the old school chemical engineering, which really has to do a lot with production of the compound, and then this very novel or forward-facing perspective on how does one engineer microbes. And then you add on top of that automation and high-throughput screening, machine learning. How do you understand all of this? How do you take the best pieces of both worlds?
It's an incredibly exciting time to be really a company in the bioeconomy. It's a convergence of a number of innovative bioeconomy technologies that are coming together at once. I think there are two impacts that we actually see directly for the Department of Energy here with Lygos' process for malonic acid. So one is that malonic acid in manufacturing processes can reduce energy costs of manufacturing. This is in some of the big areas of auto manufacturing. The second area where we're really making a positive impact on the bioeconomy is one of our products comes off of malonic acid and requires ethanol. So in a sense, we have demand for bioethanol as well, and our customers have a demand for bioethanol. And so by combining our products in malonic acid with existing technology for producing ethanol, we're really able to effectively increase the value of what today is used as a fuel, but what tomorrow could really show up in all consumer products, or a vast majority of them in the future.
In 2008, we were looking at forming some additional products out of our facility. So we formed an R&D facility, and we hired a gentleman by the name of Travis Brotherson to come run that facility for us. And from that, he actually invented the process that we now call Celery.
The real start of the project was trying to characterize how much starch was left after we had gone through our fermentations over in the conventional side of the plant. Initially, the tests that I was running, I couldn't get as much sugar as I should have to explain the amount of starch that the labs were telling us that we had. I began to do some deeper research into cellulosic processes. What I ended up coming up with was a Presto pressure cooker. After we used the pressure cooker, we were actually beginning to see more sugar coming out of this than what we could explain with the starch. We got cellulosic enzymes, started to work with that, and began to realize that we were actually, in fact, converting cellulose.
We've been very happy to successfully have that operating for more than 2.5 years. We've made somewhere between 5.5 and 6 million gallons of cellulosic ethanol since July 1st, 2014. But just within the United States, if existing ethanol facilities would adopt this technology with the yeast and enzyme that are available today, we can actually generate 2 billion gallons more ethanol out of the same bushels of corn that we're already processing. At the same time, we would be getting more corn oil that could be used for feed or for energy, and we would be concentrating and making all of the protein more digestible. So we're really not just helping our own process by having this cellulosic ethanol being produced here at Quad County. We're helping all folks that are trying to do fermentations on C5 and C6 sugars.
We identified a refinery that was in the asphalt industry on the West Coast. And why we were fortunate was we were able to step in here and essentially keep in place a tremendous workforce that had been here, many of the folks more than 20 years operating these units. It's still hydroprocessing, and the core understanding and knowledge from the processing side, the safety elements, the logistics side. We were able to save almost 100 jobs here, retrain and re-engage and redeploy them into a green economy. When I think about and now fully can appreciate the perspective of the skill sets of the folks that we have here, I couldn't be more excited about it.
We're using a renewable material. Our chemistry is simplified as compared to conventional refining because we're primarily just dealing with a triglyceride as the feedstock. When you look at the conventional product, right, it'll have like a yellow tinge to it or a color to it, whereas all of our products are very clear. they have no contaminants in them.
Today we're using primarily inedible agricultural material, mostly animal fats, greases, and oils. We have folks coming to us now on the cellulosic feedstock side, and I think that's by and large today the most exciting opportunity that's presenting itself. The next few years are going to be, I believe, dominated by conversations and hopefully successes in what people are deeming green crude. And we're already seeing that, and we're seeing opportunities to partner with those folks, taking true waste materials, whether it's municipal solid wastes, true wastes from the food industry, or even woody biomass, which I think is an extremely exciting intermediate, if not near-term opportunity.